Welcome everyone to this week's OMR Architecture Meeting. Today we have two topics to discuss. The first today is Jan Rani, who's been working on RISC-V, and he'd like to talk about introducing some RISC-V CI builds into our build process for PRs. Jan, you want to lead the discussion on that one?
Yeah, hello everyone. I will try to make it short because this is a simple thing, and I just would like to get a better understanding where we are and what are the next steps. As you all know, we don't have a CI for the RISC-V, which I'm trying to look after the code and make sure that that it works, but I'm failing at that. And the builds are getting broken every now and again. Usually there are two reasons. Either this is the consequence of some refactoring on other parts, which also touch the RISC-V part, and there is some compilation slip. I mean, missing semicolon or something, so the code won't compile at all. These are usually easy to fix, but yeah, you need another PR and then another revision, and it takes not only my time but also time of the reviewers, which I guess is also scarce. Other kind of regressions are mostly caused by adding new tests, which is a great thing. On the other hand, I'm not as fast keeping up implementing new code. And now when for example, there is a test for a new OpCode, which is not implemented by the backend, then the whole test fails instead of saying like, I mean, the test crashes because there is the TR unimplemented, which causes a trap, and then the whole thing is marked as a failed build, which makes a bit of an issue to me because I either have to fix it, which is not always easy and straightforward. And second, if I'm working on something else, I cannot just run the test and look whether it's all green or red, because I know that this is red, so I have to manually check which ones are failing or not. Yeah, so it would be really great if we can move the CI builds forward. So the question from my side is how to make that happen where we are. We have essentially two options: either run it completely in a QEMU, but the problem is that we need a really fast machine, because on mine the builds, they just take ages. I mean, a couple hours at least on my hardware, which is not that great, but still. So I think it's impractical to use that for every PR build. On hardware is much faster. I mean, on real unleashed, it's much faster. But the question is whether we do have the hardware. On that particular topic, we looked for what are the options to get some hardware donated. Actually, Boris Shingarov looked at it, so he might say more about it. But there is a little chance that we might be able to get some hardware for the Eclipse CI infrastructure, if that helps in any way. So yeah, that's the short summary of how the situation looks from my side, and now how to move forward.
Okay. Thanks. Yeah, thanks, Jan, for bringing this up. So first off, I don't think, and anybody here can certainly jump in if they have an alternate opinion. I don't think there's going to be much objection to introducing a CI build for RISC-V. I mean, certainly the problems that you highlighted are definitely issues that any platform faces. And it's certainly, if RISC-V is considered to be a first-class platform in OMR, which I certainly think that it should be, then it needs to be tested as well using whatever means we have. So I don't think you're going to get any objection to that. But if somebody has a differing opinion, please speak up. The challenges that we've had with testing on RISC-V are exactly what you highlighted there, in that it is a lack of hardware, unfortunately, and the question is where to get that hardware from. So I mean, at the very minimum, one thing that we could introduce probably immediately is a simple cross-compile build of a RISC-V backend, just to verify that any build time asserts, static asserts, things like that would fail, whether or not there's any linking issues or actual compile problems. I know you've actually experienced some of those in the past, and I'm probably one of the ones that have been guilty of causing some of those problems on RISC-V. So at the very least, that kind of thing can be done on the existing hardware that we have, probably on x86, to flush out compile problems. I don't think, like, going through the two options that you have, I don't think we do have very limited hardware available for testing. And I don't think we have a machine that's as capable of running QEMU in the manner that you'd like it to as part of the build farm. So if you do require a fairly powerful machine for that, I don't think that what we have is going to be adequate. So therefore, that option probably isn't really on the table. But the real hardware approach is I think, and I'm glad you mentioned about your company possibly donating some hardware to the cause here, and I think that that would be very appreciated if that can happen. So I don't know if and I see Boris is on. I don't know if you want to talk a bit more about what it is that you like, what the likelihood of that is. And if it is likely, then what would that contribution look like? Would it be a couple of devices that would be hosted by your company, or would that be something that we would potentially put with the other open hardware that we have at the University of New Brunswick? How would that work? I don't know if maybe Boris, you could give us a bit of an update on what you are proposing.
I'm not sure whether we're looking at a little misconception here, because this is definitely not being donated by our company. This is being donated by the RISC-V people and by Sci-5. And well, they already donated the hardware that Jan is using and that I am using for development purposes. And I reached out to their CTO because, well, it's not that I asked him. He proposed that, hey, by the way, we want to give you more hardware if that helps. And I was just, But the thing is that there's two dev boards, right? The one that was popular a couple years ago, which is, there's no way to obtain any more of those because they're not, I mean, the chips themselves, they are not, they just had one production run at the foundry and that's gone. And this is not, this is not being produced yet. And then there is this new machine which is just coming out, and they have several of them, and they're kind of still scarce because there hasn't been an actual production, like a mass production run of those. They are beta previews or something like that, and the message that I have from Unsup is that as soon as they enter production, they will just donate us whatever we need, a machine, couple of machines, or whatever. Now, where to host them, we can discuss that. I mean, we can put that. I don't know where is the other CI. Where are the other CI machines?
So the ones that aren't on the, so we have some that are from Eclipse. I'm not exactly sure where those are physically located, but the other, a lot of the hardware that IBM has donated is hosted at the University of New Brunswick in Canada, and they run it and make it open. Like they're maintaining that farm. They're providing the power and the cooling and the maintenance of that hardware while it's there, and making it accessible to the public. So that would seem to be well, that is our only option at this point in terms of having some kind of a farm external to host this. But if there was, like for example, if Sci-Fi were providing these, and they already were if they already had some kind of an external farm that they were providing other projects to use, then perhaps that is something that we could piggyback on top of as well. But I think the project, just from a consolidation of it, let's say at the UNB, University of New Brunswick.
Well, I don't see any problem with that. I mean, I don't think it means any difference to Sci-Fi whether to send that machine to UNB or whether to send it to I don't know, IBM or to Jan or to me, right? Like it just it's a matter of figuring out what is best for OMR.
Right. Can you talk a little bit about what they're willing to provide? Is it just like one board and that's all, or is it going to be like 5 or 6, something that we could actually use to to build out enough bandwidth for running a decent number of tests on? Did they say they were willing to provide?
I don't know how many they're willing to provide. I don't know. At least one for CI and at least a couple for actual development, or however many developers they are, plus at least one for CI. But I can talk to Unsup, and that right now the problem is not about how many. Right now the problem is when it enters actual production. Because there is this dichotomy before the old model and the new model, and the old model is completely gone. There is just none of them left, and the new one is kind of does not exist yet, and we're talking about, I don't know, actually I don't know what kind of time frame.
Actually, if you are talking about the unmatched, then I believe
yes, I'm talking about the unmatched.
Yes, and I think some OpenJ9 people have it. David, sorry, I forgot the surname. But the guy preparing the Fedora images claimed that he has bunch already on the J9 Slack in the RISC-V channel.
Okay, I'll have to check if he's an IBM or not. I'm not.
I was gonna say not Hung Cheng.
Yeah, there was somebody else that chimed in recently about getting something set up on their boards. I remember the name, or I remember seeing the name. It wasn't familiar to me, so I'm not sure who they are, to be honest with you. I'll have to go back and check. So So my question for maybe Jan would be, how many boards do you think you would need in order to do a decent amount of testing? So if we're going to ask for something from RISC from Sci5, what should our ask be? Like 5, 10? Is 1 enough? I would think 1 is not enough, but do you have any
Well, I would
opinion
say
on that?
1 is not enough because that's another question. Because if we are ambitious and we are thinking about J9 as well, then is the same farm used for the OpenJ9, or can it be used for OpenJ9 testing?
Well, so right now the projects are independent, but in terms of where IBM don't, for both projects, they would live at the University of New Brunswick. So they'd be they would be hosted at the same facility, I think, but the farms are actually independent. So I think you're right that if we're going to if we're going to get some commitment from Sci5 here, I think that it should apply to both projects. So you would, and if we had to have more in one than the other, I think that OpenJ9 should probably have more because there's a much larger number of tests that run longer than what OMR is capable of running right now.
Yeah, so I would the thing is I haven't seen the new one. I haven't get my hand on it, so I don't know how much powerful it is. It should be much better. I mean, the CPU should be much faster, and also you can hook in SSD, which can make it significantly faster than running from the SD card or compiling over NFS or something like that. But I would say 5 looks like we can do something with it.
Okay.
But obviously, it depends how many they are really willing to donate. Apart of that, if I can also make a comment on the QMU and the jobs. The cross-compiling jobs and the native compiling jobs for the OMR, they are already committed and used, and they are running on my board when the board is online, because sometimes I have to take it off and actually work on it. But the code is there. What can we do with with cross-compiling on some commodity x86 hardware is that we can even run the test not under a full QMU, but under the user process emulation mode, which is how I run it on my development system. The problem is this is not integrated with the Jenkins pipeline, and I don't know how to do it because you have to run it under the QMU, not directly, and this is all going through the C test, and this is area which I'm not really familiar. But with a bit of a work, I believe somebody who knows the CMakes better than me can probably use this sort of emulation to run the tests, and this is reasonably fast. I mean, usably fast.
Yeah, I have a question. When you said it takes 2 to 3 hours, is that the full compile and test?
Well, I would have to dig out some old emails, but this is a full compile in complete running Linux under system QMU.
Okay, so that time would roughly be cut in half if we could cross-compile and then just run the tests emulated.
Yes, this is totally practical. This is what I am using, and only when this passes, I run it on the board, and for final check that it runs on the real hardware. But the first level testing I always do on the OMR side on process or user level QEMU. With J9,
just going to throw this out there. What we can do is we can add the emulated job to the build pipeline, not the PR testing. So at the very least, you'll get a run for each commit that gets merged. Seeing as we only commit maybe like 5 things per day, that would be 5 runs, even if they take an hour each. It should be doable. So that way, at least you have a history of, clean build, and then something will get merged that'll break it, and then you can see what was merged. Yeah,
great. We can do that. I just only don't know how to properly hook it into the CMake, but I guess somebody would know how to do that.
So
we can get help from Devin.
Sorry, in that configuration, would you need to run that on? So I know when you wanted to run it in the full QEMU mode, you needed a fairly powerful machine. If you're not, can you run the in this other mode? Will that require as powerful a machine?
No. I mean, I'm running it on my 7 years old laptop, which even back then wasn't that great machine.
Okay, I guess I'm wondering, like from maybe, sorry, just 1 second. Sorry, excuse me. I'm wondering from if we can use Azure pipeline to run this, or would that be too slow? Maybe that's a question for Philip, because he's got a bit more experience with that.
I don't know if we'd have enough control to install QEMU on there.
Okay, but we would be able to do that on
the issue with using the user level QEMU is not only that you need the QEMU as such, but you also need like a file system image with all the libraries like libc, even the dynamic linker, and all that. So the user level QEMU can load the libraries from there, which that's just a bunch of files. But I just have them on my CI in the image of the operating system. So I don't know how that works with Azure and things like this.
Okay, I'm wondering, Adam, do you know if we have enough control over the Eclipse machines to be able to run QEMU in such a way? I'm not sure how much we can configure the hardware that we're given access to, the x86 hardware, to run something like this.
Probably. I mean, they're ours and we have all the access to them other than physical. We can talk to Raj and Joe about actually getting it done.
Okay. All right, okay, so we have a couple of things to chase down there from the Eclipse side and maybe the Azure side for running like an emulated job that we can get sort of a quick test in the pipeline. And then the ideal solution would be to get actual hardware to test on. So Boris, is there anything that is there any input from the project that you think would be helpful to get Sci5 to provide us, let's say, with 10 boards, something like that? I mean, is that a communication that should come from, let's say, an OMR project lead or an OpenJ9 project lead to request some assistance in the projects?
I don't think so. I mean, to them, it looks like to them, Jan and I are the group who is porting OMR/J9 to RISC-V. So they will just, they never, that has never been any kind of issue for them.
Okay, that's good. I mean, I'm glad you have that kind of a relationship with them. So I guess the thing then would be to I mean, I don't want to sound overly greedy, but I mean, we should try to get as many of these devices as we can, just to make the because we certainly know from other architectures that the limited amount of hardware certainly impacts the amount of testing that you can do and the quality of that testing. So I mean, we need to sort of strike a balance between being overly greedy and getting a little bit more than what we need. And so who knows, maybe starting with 5 boards each might be reasonable.
Yeah, I think if we
can get into it
show
more.
the value that we're providing, they'll be more than happy to give us more hardware.
Yeah. Okay. I will follow up with the University of New Brunswick as well, and Joe, to understand what our capacity capability is there, and if they need to make any adjustments on their part in order to accommodate a number of these devices. I imagine that they're fairly low power, so it isn't like we're pulling in 10 large servers that they need to accommodate. So it may not be too bad from a power and cooling point of view.
There still might be a power issue, but we can talk about that later.
Yeah, I've heard there may be some issues there. Yeah.
Okay, Yan, why don't I touch base with you at some point later today or maybe tomorrow, and get a sense of how the cross-compile works. And I can drive forward to look into this with Devin and Adam to see if we can hook this up to our automated farm to at least run on the build on merge using QEMU.
Great.
Yep, sounds good.
I mean, anything would help, I guess.
Yeah, I mean, it is unfortunate that we've had the RISC-V backend in the code for over a year now, and yet we've been unable to provide the kind of testing that it probably needs, even the basic testing. So hopefully this will correct some of that in the short term while we wait for a full hardware solution that we can get going in both farms. So, okay, cool.
Great. Thank you.
Right. All right. Okay. Any more discussion anybody wants to have on this topic? Okay. Right. So the next topic we have is something suggested by Philip. So some work that he wants to do to extend some of the work that's happened recently with the centralized OpCode enums. So I'll let you take it away, Philip.
Sure. Maybe I'll share my screen to open up that pull request or that issue. Let's see here. Okay, can you see my screen?
Yes, we can.
Okay, cool. So this issue kind of gives a summary of the Slack thread, I guess, since Slack eventually deletes things for us. So there was some work done a couple weeks back to centralize the OpCode enum to make it more extensible and auto-generated, so we don't have to rely on various tables having specific order and various names, I guess is the best way to put it. So I've gone ahead and extended that and implemented the same work over in OpenG9. And now I'm trying to do a bit more cleanup to get rid of some more dependencies between the two projects. So where we're at right now is we can reorder our opcodes in OMR and OpenG9 without breaking either project. That's all fine. However, we're left with these really ugly looking defines that we have in a bunch of places. So here's one in the OMR tree evaluator table for x86 64-bit. So what ends up happening is if I scroll down, we define this opcode macro definition, and we include the opcodes enum. So this is an extensible enum. So for example, OpenJ9 implements their own set of opcodes, those ones will get included first, and then they'll include the OMR ones. And all that this file contains is just a listing of opcode macro calls, which have all the metadata for that particular file. Let's get an example of this one, actually. So it should be, I think, in the IL compiler, IL, and opcodes. If I can find it. There we go. Right, so this one is in OMR opcodes. Okay, so here's what the OMR one looks like. It's a giant file. Takes a couple seconds to load. So it just calls to this opcode macro, and this file gets included. And for example, for the tree evaluator, we end up defining what the opcode macro should be. In this case, we just map it to the opcode followed by evaluator, and then once it gets preprocessed by the C preprocessor, it'll just expand into a table of things that look like, for example, min, max, evaluator. And these will map to functions, which then we index via the opcode into the table, and that's how the evaluators work. So that's all simple. However, we're left with this super ugly looking defined sequence. And the reason we had to do this was because the names that we generate here need to have a very canonical naming scheme. So it's always the opcode name, the underscore, then the opcode name, and then evaluator string. And we piece that together, and that's what ends up getting generated for that particular opcode. Now the problem comes when we have multiple platforms. So for example, I gave an example here of I think the bound check evaluator or some other one. I forget which one it was. The LU neg evaluator. So if we take a look at this one. Okay, so on x86, the LU neg evaluator maps to integer neg evaluator actual function, which is implemented in C++. However, on Power and Z and AR64, they're different names, and I'm not sure even I didn't put RISC-V here. I'm sure it's something similar to Power, but you can see the kind of difference in the evaluator naming that ends up happening. So it's not very clear, for example, if you want to look at what is the implementation of LU neg evaluator across the different platforms. Well, what do? You have to kind of guess what it's actually called, or look at this define and try to figure it out. So my proposal here is to try and get rid of this ugliness and kind of standardize the naming scheme across all the platforms. So what I was proposing is to have a function for every single evaluator and make the name standard across all the platforms. Which means we might have to introduce kind of stub evaluators. For example, things like bound check evaluator, which currently map to the bad ILOP evaluator, might have to have a stub that looks like this, just because the name has to exist at compile time for it to be resolved properly when we compile the C++ object. So this is going to introduce a little bit of a footprint increase, which I will take a look at to see if it's something manageable. And it'll introduce quite a bit of these kind of stub functions. The other thing we lose is the ability to map multiple evaluators. For example, the F2IU and the F2LU evaluators here map to the same C++ function, whereas in the new scheme, we would have actual two functions, and then inside of them, we would just call the same evaluator twice. So this is kind of something that we lose in that respect. So I just want to get an opinion or hear your thoughts about how people feel about making this change, or whether there's something better that we can do.
Do you anticipate the footprint increasing a crazy amount?
I'm not sure. I haven't prototyped the change, but it would be, well, let's see, the maximum it's going to increase is one function per opcode, so about 500 or so functions. But obviously, a lot of these have functions already there, so it's going to be quite less than that. And even in this case, it'll just be a simple stub type function, so I don't know how much this will map to, maybe like 20, 30 bytes. Times a couple hundred, might be a few kilobytes worth.
I mean, if you're willing to do the work, I mean, it'll be a useful data point to have to see what the footprint of this kind of a change would have.
Yeah, I don't think there's any way around that. I'll have to do it and measure.
Mm-hmm.
The other problem that I ran into, which is why I'm trying to drive this change is, say for example, OpenG9 wants to re-implement the iConst evaluator. Currently, it can't do that because the way these includes happen is, let me scroll down here. The OpenG9 tree evaluator will actually include, will do its own set of defines first, and then it'll include the OMR ones, or vice versa. So what ends up happening is, if I want to, for example, override the dmin evaluator in a downstream project, I can't actually do it because I have to make my own _dmin evaluator define, but OMR already creates one for me. So they end up kind of overriding each other.
Yeah, to me, the other incentive to do a change like this is related to what we can and what we cannot do regarding formal proofs and the formal definition of what each IL does. And it looks like, I mean, it was very difficult to even think about how to somehow extract or do whatever to make a sensible definition usable for a formal verification of these opcodes. So I don't really have an exact idea of what I would like, of what shape I would like for them. But certainly, I want to think about some kind of rationalization of these definitions.
I did actually find there, I think I noted it bottom down here. There is an alternative that we could do is we can blow up that define sequence into a more uglier define. I guess triple it by adding some if not defines there to allow at least downstream projects to override evaluators. That would be a net zero change, like there would be no footprint increase or anything, and things would be transparent, but we'd have an even uglier thing to look at, and the names would not be standardized across the different platforms.
Well, I would certainly welcome having the name unified, because when I'm looking how other other backends do it. Sometimes I'm looking for something that is not there. So that's fine. What I'm not really understanding, and that's probably my ignorance of the code base, is why you can't simply, if when you are extending the tree evaluator, why you can just override the stuff. The same goes for the stubs you were talking, like that you would have for example, we just dispatch to the unimplemented IL evaluator when something is not implemented. Why this can't be inherited?
I think we'll need an example from OpenGNI for that one.
So I think.
Go ahead.
Well, I'm not sure if I can I think I understand your question, and I think I understand the answer, but I'm not sure if I'm going to be able to explain it very clearly. So so typically for a lot of these evaluators at the OMR layer, they all live in the same file, like the implementation of these things. So let's say just pick OMR tree evaluator for any particular architecture is going to have dozens and dozens of evaluators. If there's one, now if a project like OpenJ9 wants to override one of those evaluators and provide its own, if they had the same name and they lived in the same namespace, you'd have to somehow prevent the OMR one from being seen and the OpenJ9 one from, and you want the one in OpenJ9 to be seen. But the problem in the OMR side is that one evaluator that you want to hide lives in amongst dozens and dozens of other evaluators. So it's not like they live in different files that your build system can just sort of pick and choose which files to include. You want the granularity to be within that file itself. I want to pick that particular function to include. Otherwise, you're going to get some kind of a linking error. So I'm not sure if that made sense, but I think we have looked at that in the past, and we've run into problems like that in the past. So, and that was the problem. But maybe if Philip's got an actual example here, that might make it a little bit more clear.
Yeah, I guess the only way to do it today, we have to put the OpenG9 defines first, because it's OMR that ends up including this opcode enum file, which actually has all the definitions of the opcodes. So OpenJ9, for example, in this case, includes the OMR tree evaluator table, but before it does so, it defines its set of evaluators. And then this guy gets included. He defines the opcode macro, and then the opcodes themselves are included. And because OpenJ9 is being compiled, it ends up including first the OpenJ9 opcodes and then all the other ones. So there's no way for us today, at least, to override, for example, any of the OMR evaluators, because if I created my own, hash-defined deep max evaluator inside of OpenJ9, well, OMR is just going to override it with its own.
Yeah, unless you added complicated logic, like complicated preprocessor logic in there to say,
yeah, unless you did something like this. Yeah.
Yes, right.
But we still have that ugliness between the different platforms where we have different names for different evaluators and different platforms, and everything is inconsistent.
Okay, thanks. I think I would have to look at the code more closer.
Okay, well, it sounds, Philip, like you've got the green light to go ahead and prototype something just to see what it would look like and what the impact would be for implementing it that way. And perhaps then we can decide on how that looks and whether that's something we want to go forward with.
Yeah, I think it'll help people to take a look at some code. It's going to be a giant PR, but mostly a mechanical one.
Can you do it on just one? I Can you do it on just one cogen to begin with, like just from a okay?
Yeah, I can do, yeah, sure, x86 or something.
Okay. Okay, other questions for Philip?
Well, maybe not really question, but it looks to me at least that on AR64 backend, this can be used also, with register definitions and things like this. The same approach that you have just defined it. Or you have this table, and then you define some macro and include the file with the table to generate the code, which, for example, I use quite heavily in RISC-V backend. So I have one huge table defining the registers, their name and things. So then all the names of the registers, the binary encodings and everything get included from the same table. So this can be expanded to maybe more areas. The approach, the technique, than just evaluators and these simplifiers and things like this.
Yeah, the other goal that I mean, I think it's maybe unspoken in a lot of some of these PRs of late, but one of the goals that we have for this project is to converge the code generators as much as we can going forward. There is a lot of overlap in the functionality between the various backends, but most of them are fairly similar in terms of what they're trying to do. So as much as possible, we'd like to come up with solutions that can be shared across the various backends, or very much look look identical. What you look at in AR64 is the same thing that you see in RISC-V or Power, that kind of thing. So that is the direction that we want to go in for sure. So exploring the use of a technique like this is interesting for sure. I think we just have to make sure that it can be applied across all the architectures. So the convergence story is happening. It's just happening very slowly when we have time, and there's a fair bit of cleanup that has to go into that, and sometimes you have to move mountains in order to make things happen. But things are so. But yeah, as we look into registers or the machine class, things like that. There are certainly opportunities to leverage this kind of a solution there as well.
Yeah, that's great to hear, because this is something that bothers me for some time. That there is especially in between the RISC-V and AR64, there is a lot of code duplication.
Yep.
Which is basically caused because I used the AR64 as a model or doing the same thing, but really there are not much differences in many cases. So this would make things certainly much better. And I wonder whether there is a way to at least start with these two.
For the instruction type metadata, I think we were moving towards the properties. I forget what they called. OMR inst.code. Yeah, these two files. We have one on Power and Z. I think x86 was the next place that we were going to do.
Yeah, that work was redone like a few years ago on x86, but I think it can be. I mean, I think that it makes sense to continue to use that, or to use that to unify with the other two. And yeah, AR64 and RISC-V can come along as well. I was going to say, Jan, that a lot of the not a lot, but a not insignificant amount of the AR64 code generator borrowed from Power as well. So I think you'll see some definite lineage between RISC-V an AArch64, which borrowed from Power, which also borrowed from ARM, 32-bit ARM. So there's lots of shared DNA between the different backends, and we just need to get that all straightened up, I think.
Yeah, the unfortunate thing with that is if there was anything wrong, the bugs are also copied over. And you have 5 bugs replicated across 5 platforms, and you're wondering, why is this even here?
Yep.
Yeah, been there, seen that.
Okay. Any other comments or questions for Philip? Okay, if not, I think we can adjourn for today. And the proposed agenda was created for the meeting 2 weeks from now. So if there's any topics anybody wants to raise, please just edit that issue, and I guess we'll adjourn now and convene again in 2 weeks. Thanks everyone for attending. Bye.